Hey folks, welcome to this NF Core training. Just give another 30 seconds or so for people to join and for it to go live, and then we can kick things off. So I'm just going to share my screen onto the training event here, and this is available. All the information is available over on the NF Core website. You'll see that this is the first of the sessions that we're going to be kicking off today, and we're running three training sessions across sort of three time zones around the world, and this is like the first of those three. And this will be across 3 different days. So you'll see there's 9 sessions in total. Here is the schedule, which can be found on the NF Core website. Right at the very top there, you'll see some information on the different events, and we're going to be kicking off here with a 2.5-hour session, and we're going to have a break sort of halfway through that. Hopefully, if you're watching this, you've managed to find the live stream, which is available on YouTube there. And I guess the key information is that if you've got any questions or anything you need to ask during this or after the event as well, we're going to be doing all of that over Slack, and that can be found in the NF Core Slack channel. So if you scroll down here, you'll see some information on that, and there is the one for this session, which is this training October 22 APAC. So if you select onto that Slack channel there, that should open something up for you, and you can sign into Slack and kick things off there as well. I know there's a couple of events around the world, so welcome to people who are joining there, and we can get things kicked off by starting off with the session on the introduction to Nextflow. This is going to be sort of 25-minute session or so, and then we're going to jump straight into developing our first Nextflow pipelines. To point out, all of the material is available online. The only thing that you need is essentially a browser and a GitHub account for we're going to be using Gitpod for our interactive environment, which is available. So without that, there's a lot of material to cover. So I'll kick things off and jump straight into discussing things on Nextflow, and then we'll jump into some practical sessions as well. So kicking things off with a kind of a little bit of background on Nextflow and sort of how it came about, the kind of problems that we're trying to solve here. Most of the time when people think about Nextflow, they think about the concept of trying to solve essentially pipelines or workflows. And you can think about these as essentially you have multiple different pieces of software. Each piece of software maybe trying to solve some problem, and sort of putting all of that together ends up being quite a difficult task, particularly if you want to do that in a reproducible way. Here's an example of an NF Core pipeline for IGA, which is ancient DNA analysis. And you can see that on the left-hand side, you've got some input files, in this case, some FASTQ, some BAM, faster file. And then what you want to do there is send all that information through each of those individual steps and get some kind of result out. So when we talk about Nextflow and kind of workflows that we're thinking about, you can think that there's typically many different tools. Each one of those tools maybe has very different requirements. And when you're running this through, we're not just running this through once. We might run through many of these steps for every sample that we have. So we end up with this kind of parallelization across the whole workflow. Coordinating that, orchestrating that can become quite complex. And that's really the kind of key problem that Nextflow is trying to solve here in terms of writing those pipelines and then running them as well. Sort of stepping back a little bit and thinking about the broader problem there. We know, and particularly in life sciences, we all now have much larger data sets, whether this is coming from sequencing data sets or imaging data sets. This kind of large influx of data has really required different approaches to what you could do. You typically don't run this analysis on your laptop, or if you do, maybe you need to scale up to a cluster or to the cloud. And you've got this concept of embarrassing parallelization, the idea that you spawn up thousands of jobs or tens of thousands of jobs where essentially the pipeline is run in parallel for every sample as well. And in bioinformatics, we have a whole sort of collection of different tools that we rely on. It could be scripts from your own lab, maybe it's some code that you take from GitHub, maybe some bioconda containers, maybe even some proprietary software. And you need to bring all of that together kind of working in a single environment and then be able to run that in this sort of scalable way as well. And obviously all the dependencies of that software is very difficult to manage. So that's again kind of base problem that we were sort of starting with, and this development began sort of coming up to 8-9 years ago now. And so since then a lot of things have changed, but a lot of things actually do stay the same, and many of these things are still very relevant today. When we think about it, there's kind of a concept of fair data, which you may have heard of a lot. And this is something which you kind of see often with regards to the data itself, but I think it's just as applicable to the data analysis or to even the pipelines themselves. The idea that we can make the data analysis findable, accessible, interoperable, and reusable. Obviously, Nextflow is kind of very key to many of those points. But also that could be equitable and scalable. The idea that you would take that analysis, run it on your laptop and scale it up into the cloud as needed, and also test it, that we can use modern testing practices for software engineering, essentially make our pipeline into components and run from there also becomes super important as well. Here's an example of a pipeline that was developed in Nextflow pretty early on, and you can see here that there's really a lot going on in terms of a modern pipeline. This has got 70 different processes to it, so it's got about 55 different external scripts, etc. And when you were thinking about how you're going to manage that, how you're going to install that, I guess the old way to do that was to go find each one of those pieces of software, maybe go into your cluster and install it, maybe use modules to install each one, but then you end up in situations where there becomes sort of dependencies, maybe two versions of the same software don't work together, and it becomes a real sort of difficult situation to try and sort of manage that and install that in this way as well. Here's a sort of expanding a little bit on that, on how you would take that. So very often people were starting, you look at a paper, maybe something you want to try and reproduce, something you want to try and replicate. And if you look, say, through the methods section, you can go through and you can see, okay, use this version of the software, this is kind of happened. Then you get a rough idea of it. But without any kind of reproducibility, sort of even in sort of the silico way, it still ends up with a lot of wasted time. Here's an example where it says that on a typical paper, you're looking around 2 months just to be able to reproduce exactly what the authors did. This seems like an excessive waste of time, given the fact that it is computational. You think that there is code, there's scripts, etc., that you could essentially publish and make available and replicate. The problem is a little bit deeper than that, though. So what we were able to show in one of the Nextflow papers early on was the idea that the application itself, when it's deployed in different environments, essentially when you take a workflow and you install it in different environments, you end up with different results. And this is what was shown here in a couple of examples. One of them was with that same pipeline I showed you before, which was for gene annotation. And here you could see that the genes which were essentially defined where the start location, the stop location is were different depending on the different environments which you installed that pipeline in. And then the same thing happens as well. We have to show here with gene quantification. So this is transcript quantification using Callisto and Sleuth here. And between the same versions of the software, everything essentially identical on just different operating systems, you ended up with the genes being called significantly different, changing. This is probably due to underlying just differences, maybe rounding differences in those libraries that are underneath there. But it ends up in a situation very kind of difficult for reproducibility. So I look at sort of Nextflow and sort of Nextflow's sort of attempt to solve this problem, but also some adjacent problems as well. If we think about what Nextflow is itself, it can be thought of as a language. So it's a way to write pipelines. It's essentially a situation what you see at the top here, where you can write code in any language. So you can take your Python, you can take your R scripts, you can take your command line tools, etc., and you wrap them in these process blocks, which are linked together with data flow programming. And this is a very kind of scalable way that you're taking components of your code and linking them together where the data is going to flow through them. You typically then will define the dependencies that you need with containers. So that's like a way where you can take all the individual pieces of the software, which is required to run the underlying sort of processes, and then you wrap all of that into a Git repository. And by sort of wrapping that into a Git repository, we get this version control, and we get sort of reproducibility and sort of modern software practices there as well. Nextflow is also a runtime. So it's also, as well as the place that you kind of write the code or write their language, it's also the runtime that executes that code. And once you run an Nextflow pipeline, you've got some multiple choices for what we call the executor or the execution platform. You can run in AWS and Google Cloud and Azure. And you've also got options for all the schedulers, so the major schedulers. I believe there's 10 or 12 or so of those, as well as Kubernetes, as well as local. And in for example, AWS, you've got sort of 4 or 5 different ways that you can run Nextflow. So it provides a lot of flexibility there. And I think one of the key things that sort of led to so much of the success of Nextflow has been this separation between the definition of the script, essentially the definition of a pipeline, and then where Nextflow runs the pipeline. And that's really meant that people can come together, can really work on the pipeline itself. They can work on the workflows in GitHub, for example, and then they're able to essentially, independent of where they're running their pipeline, maybe they're working in the university cluster, maybe there's someone who's working in a company who can work on the cloud, and they can all work on the same code base. And that's really led to the development and the sort of the growing of the Nextflow community as well. Considering about like maybe some differences now about how Nextflow works versus some other workflow systems. So you've got this concept of it being a DSL. This means a domain-specific language. DSL is written on top of another programming language. So it means that for the most part, you can use exactly what you see in the docs, what you kind of see there as part of the DSL. And then in situations where something is not covered, where something is, say, you want to do something outside of that, you've got this underlying programming language you can access. And with regards to Nextflow, that's Groovy. I should point out, you don't need to know any Groovy to write Nextflow, but having an appreciation of it underneath can help you in those corner cases as well. This is kind of different from, say, a specification, something like CWL, where you have a definition of exactly what can be done, and then sort of outside of that becomes a little bit more difficult. Nextflow's got this concept of reactive programming. This is where the kind of flow part comes in of Nextflow. So it's the idea that essentially the processes are sitting there alive, they're waiting for the data to come, and the data is pushed through the pipeline. And we'll see a lot more of this as we go through, and that's kind of one of the core concepts that we're going to be learning over the next couple of sessions as well. We have an idea of being self-contained. So each Nextflow task, when it runs in its own working directory, and it kind of runs essentially almost kind of like isolated by itself. This was kind of one of the key decisions that was made early on, and it turned out to be quite fortuitous given the rise of some of the services in the cloud, things like the batch computing services, where the concept is that each task is essentially a containerized job, and each one of those containerized jobs then is going to run on some environment. And this idea that you isolate these things ends up really very useful for things like resumability, the idea that you can sort of stop the pipeline, resume it at any time as well. And also the ability to obviously run these things distributed across many ways. And finally, the thing I mentioned before, this idea of the separation between the definition of the workflow and then where you run the workflow as well is a kind of key point, which we'll stress a few times as well. Here's an example, and this is an example of Dsl2. So this is like the first iteration of the Nextflow language. And it's useful just to point out here that this is sort of the way that how basically tasks are linked together. I'm going to show you this in Dsl2. You can think that the concepts behind it are exactly the same, even though the syntax is, we're going to learn a slightly different syntax for this. So here's a definition of a task. So you would typically start with this, maybe something you've got from the command line. You put this in your script where you're trying to run BWA mem here with a reference against a sample. You're piping that to samtools, and then you've got some output in this case, which is our sample band. Now, in Nextflow, the way you'd write this, you'd wrap this in a process block, and you can define here the inputs, the outputs, and then you'll notice there's a script section, and that script section is exactly the same as you would have it. So basically, it could be the exact same thing that you would write in the command line or that you had previously. And the key point here, I guess the key difference there from something is this concept of these channels here. So you can see that the process takes 2 inputs, and one of those inputs is from a genome channel, and one of those inputs is from a reads channel. And that's essentially the channels are sort of driving the data in, they're like linking back to here. Now, what happens if I wish to use this downstream? What if I wish to use sample BAM in the next process? If I wish to kind of do that. Well, this is where the channels again come in here. And if we see that we define another process here, you can see we've got this process index sample. you'll notice that the output of the align sample process becomes the input of the index sample process. And that is what's inherently creating this link between those two things. And then you'll see that this channels are kind of one of the key defining factors of Nextflow and how you can kind of drive this parallelization forward. Let's have a look at it a little bit in practice. This is the Dsl2 syntax. This is what we'll be looking at from now on. And you can see here it's very similar. We have the definition of a task on the left-hand side. In this case, we've got quantification task, which takes two inputs here, an index and some reads. And the script section here, now we're running Salmon inside of this. And you'll notice here that we've essentially looks again very similar to what you put in the command line here. And then on the right-hand side, we have a workflow definition. And the workflow definition essentially allows us to define the full workflow, where in this case, we can see that the quantification task takes two inputs, again, the output of the index and the read pairs channel. This is just a very kind of high level. Don't worry about, and we're going to go through this in a lot more detail in practical exercises that we go through. In terms of the kind of core concepts of what a channel is, so at a technical level, it's called an asynchronous first in, first out queue. And that's kind of what defines these channels themselves. They are typically used to link processes together. So a channel sort of sits between two processes. There's also a concept of operators, which we'll see, which is a way you can manipulate those channels in between those things as well. If you consider sort of more visually, you can imagine that we've got a channel which would contain some data, maybe 3 data sets or 3 data files or 3 values in this case. And you can see that here a process is essentially the definition of what's going to be run. And then the task is an iteration of that process. So it's essentially, you can see that because we had 3 values in this channel, we have 3 elements in that channel, you'll see that we end up getting 3 tasks being run from there. And then kind of the parallelization continues from there, and then the output channel kind of goes on. In practical terms, you can see here, we've got the FastQC channel. And you can see here, it's got simply a single file in there. So you've got data sample fast.fastq. And that would therefore, because we've got a single sample in there, when we run this process, we'll just end up having essentially 1 task being generated. So FastQC will run once. However, if we change the input, and we said, actually, I want all my FastQ files that are there, then the FastQC process will run for as many files as there is in there. And those processes will run purely in parallel as well. This is kind of a different view on that, where you end up with every file itself, every FastQ file in that channel, and creating a FastQC task as well. Okay, there's a little kind of differences on CWL and Nextflow. So here you can see that with regards to CWL, we've got this kind of concept of Nextflow containing both the language, essentially the way you write it, as well as the runtime, where CWL is kind of more of a specification there. We've got this concept as well of being the DSL, which is kind of specifically written for the pipelines as well, versus more of a declarative, so YAML-like declarations there. I think Nextflow is quite concise in terms of the way it's written. It's usually relatively clear what's going on, and that's kind of written in a very easy way to kind of see and to visualize exactly how that works. And it kind of got this idea of a single implementation, which means things are quite concise in terms of the way it's developed as well. If we look, Nextflow, I guess, is a lot more similar to SnakeMake here. I guess some of the main differences there is around the difference between a pull model, where Make is defining the outputs there and kind of pulling the data through, whereas Nextflow itself is using this kind of push model. There's support in Nextflow for really many different container runtimes, as well as for cloud as well. And that's something that's kind of been driving a lot of the success of Nextflow recently. Okay, let's now jump a little bit into deployment scenarios. So far it's been a little bit on syntax. We've seen just a little flavor of what kind of Nextflow pipelines look like and some differences. What about coming to actually run the pipelines themselves? So we've got a couple of different ways of running this. We're going to mostly do is for the workshop local execution, although towards the end, we're going to see, in the 3rd day, we're going to see options for running in cluster and cloud. And just to highlight what these kind of look like. So when you're running Nextflow locally, you've got usually a single virtual machine. Maybe you've got like your laptop or a workstation here. And when you run Nextflow, each single task can either be containerized or not, but it runs essentially on the operating system. And the files, the intermediate files or the input files, etc., typically on the local storage there. So it's just a kind of basic execution, Nextflow run. It's kind of running locally in this way. When you want to scale things up and then you want to really use some more distributed compute here, Nextflow can connect in with clusters. So this is typically what we call centralized cluster orchestration. It's where you're submitting to, for example, a Slurm cluster. Nextflow will wrap each task into the Slurm job. And then from there, it's going to send each of those to their cluster, which is going to spin up the job, et cetera, and sort of take care of the scheduling from that. Here, you're typically using a shared file system, something that both the cluster node can access, as well as Nextflow, the head job in this case, for running that. And it ends up to be a very popular way for running academia, or people who've got sort of large setups there as well. What's become really popular in the last couple of years is these managed services in the cloud. Here I'm showing you AWS Batch, but there is exactly this sort of very similar setups with Google Batch and Azure Batch. And in all these cases, Nextflow is submitting the task to the Batch API. And from there, that Batch API is essentially spinning up resources in response to the task being submitted. What's great about this is it means that you can spin up resources on demand for what you need, and you really only pay for them for when they're being launched. This means that, for example, if you have data coming off the sequencer, or maybe you're in a situation where you are basically just need specific resources for a particular analysis at one moment in time, GPUs or something particular, high memory machines, that allows you to use those resources just in that moment. And then when you stop using them, essentially, you're not having to have any ongoing costs with regards to that. The data here is typically stored in some sort of object storage. In this case here, it's like an S3 bucket. But there's a whole bunch of other choices as well for doing that as well. Also another option which is available, which is kind of going beyond the managed services in the cloud, is this Kubernetes-like execution. Here, Nextflow submits each task as a pod. And those pods then in turn sort of spin up virtual machines, and depending on the setup that you have. There's a little bit more work in terms of you have to manage that Kubernetes cluster yourself, but we see this as something which will have some more prominence over the next couple of years as Kubernetes becomes a little bit more mainstream, and there's more sort of management services for that as well. Okay, switching gear a little bit now. Kind of thinking about how that works. So here you've got a little bit of a description of how it would work with Nextflow. You've got your script, Nextflow run local, and then that would run on a local machine here. Nextflow essentially got you can think of this as not having any configuration here. That kind of is the default way of running. If we were to add some configuration here, and you'll notice that the script stays exactly the same, but we added some configuration here for running on Slurm. We could define our executor, we could define a queue, some memory, CPUs, and maybe a container image here. And if we ran Nextflow run with that, we would see that Nextflow would submit each of those tasks then to the Slurm executor of this. And this would be something we would put in our Nextflow config file. We could simply then, if we wanted to take that and then run that same thing in the cloud, we could simply switch out the executor here, say I want to run that in AWS Batch. And Nextflow would submit each of those then tasks to the batch executor here. I think the key thing here, the finding there is that we're really kind of got these abstractions for queue, for memory, for CPU in this case, which really takes care of many of the details underneath. And you'll see this in the last section. We're on the third day, we're going to go over some of this. We'll see how sort of easy it is to define those things and really keep these pipelines kind of portable as well. Okay. How is that portability possible? Because how can we just simply switch out an executor and do that? Well, the key thing is to really obviously write our pipelines in a portable way, and there's a few things that we can do to that. But a key driver of that has been containerization, and containerization was something that was sort of thought up quite early. Nextflow was created actually just prior to the release of Docker. And as Docker came out, it was really sort of fortuitous timing with that. It sort of embodied a lot of the ideas that we sort of wanted or needed for Nextflow in terms of its portability there. you can think about containers were typically used and still are, for the most part, used for long-running web services, for development of applications on the web, and then running those in environments like the cloud. Containers weren't really necessarily at that moment sort of thought about for being used for data analysis or data pipeline applications. And we sort of took the idea and thought of ways that we could sort of use those into this state. People previously were using virtual machines, and in some cases still are using virtual machines or VMs for those kind of applications. But there's a lot of downsides to running the virtual machine. You have this, I call it they're very large, typically, often many gigabytes for launching them. That means the transport of these things around is quite long. They're also got a very long startup time. For us, we want to spin up tasks very quickly, hundreds and hundreds or sometimes tens of thousands of tasks, and we can't be passing around these very large sort of virtual machines for doing that. The tooling around containers has also been very, very useful. So the tooling around Docker for being able to build them, for being able to store them in registries, etc., can all be used exactly as how it can be used for writing pipelines and for the kind of pipeline software that we want. And we've got this concept of a build on top of these containers as well, and all of that has sort of helped in terms of gaining popularity for them. So Nextflow has support for Docker very early on. There's also support for 3 or 4 other runtimes now as well. So if you run in a cluster, you'll often be using Singularity there or something similar, which is really doesn't have the kind of problems with running it with elevated privileges, etc. The concept is all very the same. The idea that each Nextflow job, or each Nextflow task, becomes a containerized job there. And from there, the containerized job is run on your HPC system or run on your cloud in a parallel way as well. Okay, when to use containers? I would say I would always, and this is maybe something you can get out of this workshop, out of the containerization section. There's really that we'll be taking on later today. There's really a whole bunch of really positive things to use containers, and once you get into it, it's very, very kind of useful for your work as well. Okay, a little bit on Nextflow. So Nextflow's been growing. It's sort of on the community side of things. I know that there's going to be more sessions later on in the other days on NF Core, but just a sort of touch on the community aspect. So Nextflow's been growing pretty rapidly the last couple of years now. And a lot of that growth is not so much like contributors to the runtime or the Nextflow thing, but also to sort of to NF Core as well, where people can really come together, build up those pipelines, etc. as well. If you're looking to do Nextflow development, though, so some extra tooling which is available here. There is point out that there's some editors. We're actually going to use some of these in a moment, where we're going to be developing our pipelines with the syntax highlighting here. And just going back to the point on NF Core here. So this has been a really success developed from the community. We have support from Chen Zuckerberg Initiative for both Nextflow and NF Core, so I should point out that now. I don't want to go too much into there, but you can think of NF Core as a collection of not only fantastic pipelines which you can pull from, content which you can use straight away, but also a collection of tooling which provides you with best practices for how to structure and think about building your pipelines, as well as a whole fantastic community of people who can help you with development and running of those pipelines as well. Okay, I'm going to stop sharing this screen here now, and we're going to move over to the section on the actual practical training. And for that, maybe we can place in the chat the training itself. So I'm going to find this over at training.sakara.io and share my screen there. Hopefully we can all see. Okay, so this material, I should point out, is always available. So you can find this anytime. So don't worry if you miss something or you want to come back to this. This will always be here. Here you'll find all of the information for what we're going to basically be following for the majority of the rest of these workshops. And if you go down here, there's a little bit of background. Hopefully we've kind of covered a little bit of the overview so far. On the left-hand side, you can see we've got this environment set up. And this describes a little bit if you don't have if you want to run this on your own laptop, if you don't want to use the environment that we're providing here, you can do a local installation here. Now, we're going to be doing 1.2. We're going to be using the Git pod environment, but I'll run you through this just in case when you want to go run this. So outside of this, the main requirements for running Nextflow is a POSIX compatible system. So that means typically Linux or Mac or Windows subsystem for Linux. And the requirements there are having Bash. So basically, if you've got a command line, you're good to go. Java 11, which is pretty much available everywhere, and then some optional ones which are here for running sort of some of the work that we do with Docker and Git, etc. There's a couple of other optional ones for this workshop for running this. We don't really need to see them. We've got GravViz, which is just more for visualization of the figures, and the AWS CLI if we want to run in AWS later on for some of the workshop. To download Nextflow, you've got a couple commands. You can use this wget here, which will place it, basically download a single file, which you can then either move onto your path or make executable here. And then you've got a couple of options here. Let's jump straight though to Git pod itself. So Git pod is it's essentially like a containerized virtual environment that we can run here. And if you select where it says 1.2.1 Git pod quick start, and you select that there, this is just going to bring up essentially a Visual Studio Code environment, essentially a container with everything that we need for the training here. So it's got all of the data that we need. It's got Nextflow installed. It's got several things, and it might just take a couple of minutes to do that through. You may be asked as well to log in there to GitHub to do that. So I'll just give you a few seconds here. One of the nice things about this is you've got on the left-hand side, you've kind of got a file browser. So if you're used to using this, you can access that information here. You've also got a terminal down here. And then we've also got like a text editor up the top here, which is very useful for us for when we're editing this text here. I'm going to try and zoom in a little bit and just going to shrink this one so hopefully you can see my screen and the text nice and clearly. Okay, there. And I'll just give you 30 seconds or so to bring that up. Hopefully everyone's got access to that. These environments, if you come back to this here, it should stay available. And if you want to, you can actually log into Git pod and see your different workspaces that you have up here. You'll notice at the beginning, if you're sort of interested in this is actually taken. All this is doing is taken from the actual public training itself. So we have a Git repository, which is under the Nextflow public training. I'll just paste that, show you what this looks like in here. And then what we're simply doing here is we have a public registry, a repository here. So this is like the public repository. And inside of that, you've got this Git pod YAML file. And by putting this Git pod YAML file in here, we're defining exactly what this should look like. So basically saying how to install Nextflow. We're putting, for example, some VS Code extensions on here. So we have the Nextflow syntax highlighting, etc. A couple of other things as part of that as well. So that when you can simply put Git pod at the start of this address, it brings up this for us as well. Okay, I'm going to close that there, and I'm going to get started. So we're going to be following through the material which we have in the public training there. So hopefully everyone's good to go with that. Just going to paste this one in here, and we're going to start from a very kind of a very simple pipeline itself, just a kind of getting started with Nextflow. So we're going to jump to section. It's going to be, I believe, section 2.2. So your first script here, and this first script it's a very basic pipeline. It's got two processes to it, so essentially two steps. And the way that it's written in a way where we're trying to show a little bit of everything that sort of happens in a basic sort of Nextflow syntax. So we've got definition of processes. We've got some channels which we're going to be using, defining those. We've got some parameters. We're also using software which everyone has got. It's just using basic command line tools here. But we're also doing something that often happens in sort of bioinformatics or data pipelines where we've actually got some files that we're going to create. So we're going to create some files, those files we want to run in parallel. So we want to run each of them through there as well. And then from there, we're going to sort of process the result of that and get to the end of that there as well. Okay. So I'm just going to walk you through this, and I'm going to show you first what's happening, what's happening before we even get into the Nextflow part of this. So you'll notice that there's a definition here of the parameters, which is just, in our case, a single parameter, which is called hello world. And we're basically taking that hello world string and we're pasting it into this section here, which is simply going to take the string and split it into two files. And then we're going to take those two files and convert them to uppercase. So before we're going to go into the Nextflow syntax, I just want to make sure it's kind of clear that I guess what the non-Nextflow pieces are doing here. So I'm just going to close that there and run you through that, just sort of copy and pasting the actual pieces without Nextflow itself. So the first script we can see is simply taking exactly like you would do from the command line. It's actually just saying here, it's going to say printf, and then we've got this piece which is the script itself. So we're taking hello world. This is our parameter that we have there, and then we're taking that and we are piping that to a command called split. Split is just a command line tool, so you'll find that you've got it on in your terminal there. And then we're just splitting it on 6, which basically means based on every 6 characters, we're going to split it. And then we can give this a name, and this just means like chunk. So this basically is going to create for us 2 files. You'll see both prefixed by chunk, and it's going to split hello world into 2 files because you can split this into 2 here. So if I do this and I say ls on chunk, you'll notice that there is 2 chunk files that have been created here, chunk AA and chunk AB. And if I was to do a cat on them, you'll see that chunk AA contains hello and chunk AB contains world. So the pipeline is simply taking a string, splitting it into 2 files. And then the next process of that, the convert to upper process, all it's doing is it's taking on each file, it's essentially saying cat on the file, so cat on chunk AA, and then it's piping it here to another command line tool, in this case, which is just converting the lowercase letters to uppercase and really just printing it to the screen. So I'm just going to allow text space there, and you can see it's taking world, and making it hello, making it uppercase hello, and world uppercase world as well. That's all our pipeline is doing. So don't get too worried about the specifics kind of beyond that. It's really just taking those 2 things and doing it. Now let's go on to the Nextflow part of that. So what are we doing when we're seeing this in itself? Well, let's have a look here. The first thing you can see is we've got a shebang definition. This is something you'll see at the top of your pipelines often. It's not necessary to place it in there, but it's obviously good practice for you want to call those things. You can see we've got a first thing, which is a definition of a parameter. And you can see this because it's got this params dot, in this case, greeting. And this means that greeting is the name of our parameter there. Parameters are a bit special in Nextflow. They can be defined in many places. So you can define them in the script like this. You can define them in a config. You can define them in the command line. You can have a parameters file where you define them. And they're often used in this way, where you can essentially have a default that works well, and it's essentially always in the script. And then you can obviously overwrite those parameters to run here. The greetings channel, the line 4 here is our first experience here with a channel. And here you can see that we're using what's called a channel factory. And this is the most basic channel factory, channel of. And what this is doing is just taking the parameter .greeting, so that the params.greeting, this string, and placing it inside this channel, greetings channel. And you can see this is like an assignment. So we're giving this name, greetings channel, to the contents here. Next, we've got the definition of our 2 processes. And our processes, the first one is called split letters. It has a definition. This is the name of the process. Here you've got this curly bracket. So everything between here and here is the definition of that process. And this process is fairly simple. We've just got a single input. You can read this as it takes a single input, which is a value X, and it has an output here, which is path chunk underscore star. What this means is it's going to capture all of the files which match this. You can tell these are files from this path there. So capture all the files that match that and place that into this channel. We've gone over this section here before. Jumping to the convert to upper. Very similar. We've got convert to upper, the name of the process. We've got the path Y. So now instead of taking a value, it's taking a path. And you can think most of the time in Nextflow, you're either dealing with values or paths, and paths are particular because of what has to happen with the staging of files, etc. And in this case here, now convert to upper, the output is simply just capturing the standard output. So you don't see too often, but you'll often see if you just see, well, I want to basically capture that output and place it into a channel. I should point out here that in all these cases, the input and the output of all of them are channels in themselves. So we're essentially taking inputs channels and we're creating new channels, which are output. How do we actually call these things then? How do we take the split letters and convert to upper? Well, we've got this workflow definition here, which actually calls, sort of references the sections themselves. We're defining our letters channel as taking the split letters and we're passing it a single input here. So we've got split letters, which is being receiving a single input, which is our greetings channel. So our greetings channel here is essentially the input that goes into there. Now, the letters channel in this case, the letters channel is the output channel. This is, again, it's like an assignment of a channel name. So we're saying the letters channel equals this here. And then likewise, we can say the convert to upper takes the letters channel flattened. And this is our first example of an operator. We'll see how this works in a moment. And finally, you can see you're just taking the output of that, which we are viewing here. This is, again, another example of an operator with this syntax here as well. Don't worry if you don't sort of get this first time. We're going to go through all of these things in a lot more detail. But let's start running this pipeline now and see what we can get out. There's a full definition of what each one of the lines is doing. But I want you to first try this and hopefully just confirm everything is working. You could say Nextflow info here. And this is going to make sure that Nextflow is installed. You can see I've got the version of Nextflow I have, and etc. And all of that information there. If I say Nextflow run, typically now you can point to a single file that you want. So this is, in our case, we've got this file, which is hello.nf. I say hello here.nf. You can see that the pipeline will launch. And I give it a second there to launch through. Awesome, and you can see that it's run through there now. We've got split letters, which is run once. So you can see this from this one of one. So split, we could say the process split letters had one task. And then the second process, convert to upper, had two tasks. And you can see this from this 2 of 2, which ran. And on the bottom here, you can see that the output, which was printed, which is in our case, the view of that channel, has created hello world. I want to run through this again, see if we can see any difference. So I'm launching again, everything's exactly the same there. And you can see I get hello world. When you run this, you might see some differences though. Maybe you'll see in some cases, like here, where I've got world hello. And the reason for this, the reason why we're not being hello world or world hello now, is that this second process, this convert to upper, the tasks are running through purely in parallel. So they're really at parallel at the CPU level. When things are in parallel, it means that they're essentially running exactly at the same time. There's no sort of difference between the two, and therefore we don't know exactly which one is going to come first. And in this case here, you can see that in the first case, world hello ran first, and the second case, hello world. The first case, hello world came first. And that kind of parallelization, it's only over 2 files here, but you can imagine when you're trying to run this over hundreds of files or across each of your samples, and maybe it's not on the local CPU, but it's running out to in a distributed manner. I mean, clearly powerful. It kind of flows through the rest of the pipeline as well. What about some other things that you can see here that are interesting? Well, one thing to point out is that you can see that convert to upper here has run 2 of 2. If you wish to see each one of those itself, and this is in the thing, I'm just going to run the same thing. I'm just going to place this thing called ANSI log false on that, and this is going to split out each of those processes. So Now, instead of it having showing you only the processes, this is going to split it out, and you're going to see each individual task being shown here. So you can see that now we have split letters 1, convert to upper 1, convert to upper 2. This can be useful mostly for teaching. When you go to run and practice, obviously you may have hundreds of tasks or thousands of tasks. You don't want each of them. It's much more useful to be able to see exactly what's taking place here for being able to individually see those as well here. And the other thing that you might notice is what is this kind of lettering on the side here? Well, this is what we call the task directory hash, and this is essentially a unique hash which is generated by looking up all of the inputs of that task. And this will come through to what we'll see in the resume function in a moment, but this essentially is a way of both the working directory of where that task runs, which is inside in the working directory, as well as a unique identifier for that task, and it becomes very useful for what we're going to do. I'm going to open up that file now, this hello.nf. I can find it here somewhere. And you can just double click on the left-hand side if you wish, and you can bring that up here. It's my terminal. Okay. Now let's imagine that we're happy with the pipeline. It's kind of working okay, but we want to make some changes, or maybe we made a mistake and we want to fix something up here. In this second process, convert to upper now, instead of it being convert to upper, I want to change this and make it reverse. So imagine I made a mistake in my pipeline. I wish to do that. I'm going to save that. So when I'm saving, I'm actually just pressing Command S here. If you wish, you can also always say file, save, and all of these things here. But I'm just pressing save behind the scenes. And I'm going to do everything exactly the same now, except I'm going to press -resume. And notice it's a single hyphen there. So I'm saying Nextflow run -resume. And I want you to follow through with what happens here. You'll notice that when it launches, that the first task itself here, split letters, is cached. What that means is that the first task didn't actually have to run. It was using a cached version of that task. The second task, though, the second process here, convert to upper, actually ran. You can see 2 of 2. And now instead of converting to upper, it's reversed those for us. So that can be kind of useful if you would imagine that you're running through the pipeline. Maybe there's an error, maybe the pipeline stops for some other reason. With Nextflow, you've got this ability to both modify and resume, but also just resume itself. If I run Nextflow run-resume on this, you'll notice that it will run through, but all of the tasks will be cached. This example is a bit trivial. It only takes a few seconds to run through the whole pipeline. But if your pipeline takes minutes or hours or even days to run, then this feature becomes really invaluable. And we're going to see some more on the debugging of that in itself. The way that it works, though, is I also want to point out, notice how that in this first case, let's say, you can notice here that A, B-D8, so the split letters task has this hash. And because we used resume, essentially Nextflow looks up all of the information, all of the script, all of the inputs, etc., and it determined that the hash was the same and that the task had been run successful previously, and therefore you end up with the exact same hash ID there. So the task directory stays identical based on this information, and that's what produces that as well. What about if we wanted to change this? So I'm going to go back and remove my changes there. I'm just going to keep that the same so as we had previously. Often when we're running these pipelines, though, we don't just want to run the default data through. We want to run through something a little bit more interesting. And here you've got the hello world that we're running through as I read. What if we want to change that? So I'm going to say everything else the same, Nextflow. But now if I want to change a parameter from the command line, I can define that by using not a single dash, but 2 dashes for the name. So dash or hyphen greeting itself. Then I can put in whatever I want here. I could essentially change and override what I want to place inside there. I'm just going to put in here and copying from the material there, bonjour le monde, and run through this and see what happens. you can see that this pipeline is launched now. And notice that a couple of important things. The first thing is around convert to upper. Instead of running twice, convert to upper has now run 3 times. And the reason for that is that split letters has essentially split our new string. And Bonjour Le Monde is not split twice, but it splits 3 times because it's obviously longer. And you can see it, this is the 3 pieces that it gets split into it and then convert to upper. It's an example of the parallelization. If I was to sit this here and I said actually not Bonjour Le Monde, and I just put whatever I wanted, some long sort of string in there, imagine my file was longer or whatever there was inside of there, then we're going to get that basically being processed however many times there is. And now you can see that we get this parallelization of whatever we have there. Now, I'm showing you here strings, but this could be the exact same thing with files. The concept is exactly the same, and we can see that we've used this structure of defining these processes and how we can manipulate the channels to see that out there as well. Another thing that I want to maybe point out here, and something that we haven't seen, is this concept of the operator here. And this operator here is actually doing a lot of the work. So I'm just going to cut this for a second here. Let's just take away the operator first. So I'm going to take away this flatten, and then I'm just going to do a view on this exactly itself. And the first thing I want to do is actually just to view that. Okay. Just go back to the basic one here. We're just going to remove that and run as default. So the flatten is doing something important here. What the letters channel in this case is generating is actually a list of files. So here you can see hello world. If I don't use the flatten, you'll notice that there's no parallelization. And the reason for that is if I do here, letters channel, and I'm just going to do a dot view on this. And dot view is very useful. You can see the syntax is actually very similar. This is essentially the equivalent here. But what this is doing is going to allow us to view what this is. It's a little bit like print, but in this case, it's going to allow us to view the contents of that channel. I'm just going to remove this for a moment and save this. So just what basically, when we get to this stage here, what is actually this containing? We run through that. Okay, just to show you here, this is this letters channel that we're viewing. You'll notice that it contains 2 files. It contains the chunk AA and the chunk AB as we expected, but it contains them in their full path, first of all, because these are a file object, the path object in this case. And that means it's going like the actual full path of it. Although as far as we're concerned, we can just simply use this chunk AA, chunk AB, because Nextflow is taking care of that behind the scenes. And the other thing I want you to notice is these square brackets. What this means, the fact that this is on the same line, essentially within these square brackets, means that the output, the greetings, the letters channel here is a single element. It's made up of a single element. Let's change this before and what we saw with flatten. What is flatten actually doing here? Save this. By using flatten, it's taking that essentially single object, which is made up of 2 files, and it's flattening it out so that it now is 2 individual elements inside that channel. And it's the fact that we split those into individual elements is what drives the parallelization. It's what really splits that up. Now you can say, okay, that channel, letters channel, has those 2 elements or 4 elements or 20 elements, depending on how we set that up for running that through. And that's how it works. I'll show you one more thing, and then before we take a short break and jump into the RNA-Seq pipeline. One thing else that can be interesting to look at is notice how this location of this file and how it's inside of this work directory. So I'm just going to remove this and go back to the default here. If we look inside here, I'm going to firstly remove my working directory. So remove rf-work, and this is just to show you so it's nice and clear, and I'm going to run through that again. Every Nextflow task, remember, is self-contained, and it's self-contained within this working directory. So if I go cd work here, you'll see that if I do ls, you'll notice that there's been 3 working directories which are created here. So inside of work, and these are from these 3 tasks that have been generated. Now, if you don't delete your working directory, essentially will stay there. You can see the 17, 60, 73. Let's go into the first one. So you can see that our first task that letters was 73. So I can go cd 73 and then do an ls. And you'll notice that inside that directory, there's another directory, which has got this longer sort of hex number here. And this one is 8A, F6, etc., all the way through. And I'm going to go inside of that one. And then if I look in here, I'm just going to show you sort of firstly, the first case, if I just do ls on this, you'll notice that there's the chunk AA and the chunk AB. So the tasks split letters ran inside of this working directory, essentially was run from that location. And the files which got generated, chunk AA and chunk AB, were placed there. Now let's consider the second process and the tasks related to that. So 6D and 70AB. I'm going to clear this. I'm going to go back. So this was 73. Can go back one more. And let's go now into 6D and have a look into there. Again, there's another task directory inside that. And now inside this one, if we do, you'll notice that there's chunk AA, but notice how it's like bold in a slightly different color compared to that. Well, the reason for that, if I just look at the full sort of list of that here, you'll notice that chunk AA is actually pointing to, so which is like it's symbolically linked to the original location, to the previous processes working directory. And it's that, in this case, when you're working in a shared file system or when you're working on your local machine, for example, Nextflow simply just symbolically links to the task above and then uses that. Now, this approach is really good, really useful, but if you're running in, say, for example, a cluster environment, or if you're running, say in the cloud, well, cluster's actually fine typically, but if you run, say, in cloud, you have to like take care of those files and stage them or treat them differently. And this is the whole reason why we treat basic objects, strings, integers, maps, etc., different, which we usually define them as value, versus what we do with path here as well. Okay, that's the basic part of running our first pipeline there. I'm just trying to see if there's basically on time. Maybe Chris, you can let me know if there's anything, if we're all good to go there.
Yeah, I think that's fantastic. I think now's a good time for a break, and then after that we can come back and start talking about the sort of proof of concept RNA-Seq pipeline, as well as a little bit of Docker.
Awesome. Well, thanks a lot, folks. I'll pass you over to Chris now. I think we're going to have a short break, and then yeah, when we come back, we'll jump onto that. See you all shortly.
Cool, wonderful, perfect. Thanks, Evan. So let's take about a 10-minute break, and we'll come back. Like I said, we'll start talking about the RNA-Seq proof of concept pipeline. So yeah, go away, stretch your legs, get a drink, and I'll see you in 10 minutes.
Hey, folks.
Okay, just another 10 seconds and we will start the next part of the training. Right screen, 1 second. Okay, welcome back everyone. Before we go any further, I just wanted to remind everyone that if you do have questions, the best place to ask those is in our Slack. So if you're not already a part of our Slack community, you can join using this link here. And any questions you can just put in this training October 22 APAC channel here. And we have James, who's part of the NF core team, sort of monitoring that channel. And if there are any questions that he can help with, he'll jump in pretty quickly and give you a hand. So we will continue with our workshop using Gitpod. So what I'm doing here is just creating a new channel, a new instance rather, using Gitpod. So just pulling in that container again. If you hadn't done this already, it's just going to take a few seconds to spin up. It just takes a wee while to pull in that container. And what we're going to be doing is kind of taking it a step further beyond what Evan has just been showing us, with actually developing kind of a proof of concept RNA-Seq pipeline. So everyone should see this again. Again, remember that we have this training material up here if you want to follow along using that. But other than that, I'll mostly be following along with this just in the training link as well. Okay, so off to the right here, we're going to be talking about this RNA-Seq pipeline, like I said, and we have scripts 1 through 7. All of these are sitting there. You can execute these from your command line. But first things first, let's just start off with script 1, and we will talk about what's kind of in this script. So we can do this with a normal Nextflow run execution. We typo there. Script 1 NF. And as we can see, the same as when Evan ran his hello world example, it just takes a wee second to spin up. It's going to give us our Nextflow version number. It's going to give us a sort of run name revision. And here we're just seeing a printout of reads, workspace, NF training public, the training data, as well as what's in here. So going back up to the script and actually looking at what is in that script, we can see that we have these 3 lines here. With this params.read. So this is kind of like parameters. Parameters are quite special. Here we're really just bringing in strings. So here we've got the project directory, which is basically where we're sitting at the moment. So this is actually quite neat in that when you're using the project directory, it's using this as a relative path, which is a lot better than hard coding in where you're actually trying to like store this data. It makes the pipeline much more portable. So here we have some data, which is this FASTQ files from the chicken, from the gut. We also have this transcriptome file, as well as this multi-QC folder. And here all we're doing is just printing print line reads parameter.reads. So what we can do is we can just change this. This is just a string. It doesn't really matter what we actually put in here. We can just change this very quickly to lung. For example, control save, so you can know what I'm doing, and we can just run it again. Cool, so we see that there's a new run name, new revision, and we just sort of see the output here. But in reality, we could just kind of change anything into there. We don't actually need to have anything in particular, because Nextflow is just treating this as a string. Again, Nextflow run, and we see this big long string. So at the moment, we're not really doing anything special. We're just kind of importing these strings, which is the front end, which is a project directory, as well as this kind of just text out the back. We can also kind of override this in the command line. So if we want to just change this here, we could do something like data gggal. We'll change that back to gut. Let's just do 1 and 2 dot fq, and we'll close that off. But again, what we can see here happening is just that it's run through this little script. Up here, it's still saying lung, but down here, because we've overridden it in the command line, we can actually say gut. What we could also do here, we'll come back to this a little bit later, but because this is just a string, it's not actually doing anything, we could add like a glob. And again, it's just going to print through and show us just that string of text, nothing more at this point. So what we're going to do is, let's just jump down to the script pipeline. This is where the actual rubber hits the road, and that we're going to ask you guys to actually do something and actually try and participate in the training. We will ask you to do these exercises here. So you should see this in the training material. And what you can do is modify the script one, the same as what I've been doing over here. And you can add another parameter called outdir. So this is the output directory, or what we're going to use as the output directory. So you could add that in as another parameter. If you get through that really quickly, you can also try and add in this kind of log info. Log info is a really good way of printing out some material to your terminal. And here we're just asking for a multi-line string. If you're familiar with some sort of basic coding concepts, this shouldn't be too hard. But if you don't know, that's okay as well, because of the answers just down here. So I'll give you a couple of minutes just to quickly have a go at that. And yeah, and we'll come back again in a couple of minutes. Okay, let's just jump straight back in. As you can see, I've already sort of copied and pasted some of the answers in just to keep things moving nice and quickly. So what we can do up here, you can keep defining these parameters at the top of the pipeline or of a workflow. So here we're just going to define params.outdir. Again, we could sort of call this anything we want. Today we're just going to call it results. Here we're still just going to keep our print reads. Actually, no, let's remove that because we don't really need that anymore. And we can just use this log info. So here we can just put in any text we want. Here we're just calling RNA-Seq pipeline, and we're just going to print out what we have here is the parameters with the transcriptome file, the reads, and the output directory, which we've already just defined up here. And here we've just got the 3 quotes sort of containing all of this text. And down the bottom, we have this strip indent, and that's just going to remove some of the white space to make things nice and pretty. So again, we can quickly control save, and we can just run this again. We don't actually need that text for now. And what we should see is this print nice and quickly. Might make that a little bit bigger for everyone to see. Great. So now again, we can see Nextflow's run. We've got this launching script, script 1. It's given it another name, another revision number. And this is the log text that we've just added in. So again, this isn't anything that we've really changed, but we're just printing out the reads, transcriptome file, in this case, the output directory, which we've just defined. Great. So with that, we're actually going to keep building on this pipeline. We're going to jump to script 2. Let's close that one for the sake of read. So all we've got in here is just the exact same text that we've just added in. So you can either choose to continue with script 1, kind of keep adding these things in as we go, or just jump through the different script numbers as we sort of progress building this pipeline. So here we're going to add another sort of 2 parts to this pipeline. The first is a process. So again, this is what Evan touched on before, is that with Nextflow, you kind of have these different ideas of channels and processes. So the processes is really where the actual script is happening. And what you typically find is 3 main parts to a process. The first being the input, the second being the output, and the third being the script we're actually going to run the code that you would normally expect to see in a pipeline. So with Nextflow, you sort of define the inputs and outputs. There might be paths, there might be values. You can sort of add different parameters to kind of tune these if you need to. But here we're just going to input this path, which is transcriptome. This is kind of like an arbitrary name, but what you can see here is that we've called the input transcriptome, and then down here we reference it again in the actual script. And this is where Nextflow really kind of starts to integrate different scripting languages and different excuse me, inputs from different places. So because we have transcriptome up here, we can just reference it with a $sign down here. For the output, we're just going to specify salmon index. It's kind of like a specific hard-coded name in a way. We also see that here. And then, of course, as I said before, we've got the script, which we're going to run salmon index threads. Tasks.cpu, that's just another part of Nextflow, and then we can actually specify how many CPUs we want. We'll talk about this a little bit later about how you can use sort of different directives and different processes to kind of tune this, depending on what you're actually trying to run. And as I said, transcriptome and salmon index. Down here, we just have the actual workflow instance. This is actually going to be executing the process. So the index, which is going to be taking the params.transcriptome file. So this is where we're actually referencing the input that we've defined up here, which is this path to the transcriptome file. So let's just run this. It's probably the easiest way to see what's going on. And what we'll see is when we actually run this is that it's going to fail. So the reason this is failing is because we don't actually have salmon installed on this computer or on this instance. So you just type in salmon isn't found. To get around this, we've actually included an image of salmon in a Docker file. And we will talk about Docker files more at the end of this session. But for now, all we can do is just quickly add in with Docker. This script is going to know to go away and look for a Docker file and include it in this pipeline. It's going to act as the source of this tool, and we see it runs nicely. So again, what we see is we've got this pipeline's been executed. We can see this log information, and here we can see this index process, 1 of 1, being executed. So you don't really want to have to write with Docker in every execution of this file. So what you can do is actually include this information in a config file. So over here in our working directory, we have this file here called Nextflow config. And here we have some information already about the container and where it is. So this is just the Nextflow RNA-Seq container. We have some run options. Again, I'll come back to this later, so don't worry about it too much now. But what we can do is just do docker enabled equals true. And we can save this. We can get rid of this from our command line, and we can just click run again. Cool. And now we have this index run successfully. Nextflow has known to use this config file, and it's enabled Docker for us automatically, which is really fantastic. So now we don't have to type that in every time we want to execute this piece of code. So what we can do, let's clear that, is jumping back to the training material. There's a couple of exercises here that we could have a wee go at. The first we've already done by adding Docker enabled equals true into that pipeline. But we could also try and print out this index channel using the view operator. If you remember back to Evan talking earlier, he's actually used this already, but I'll give you a couple of moments just to try that for yourself. And as an extension of that, we could also try and modify the number of CPUs that's being taken up by that process using a directive. Now, we haven't talked about directives yet, but there's a little bit of information about it here, as well as the answer if you get stuck. So I'll just leave about 30 seconds for you to have a wee go at that. And I'll just check if there's any questions that are coming through that I can address on the fly. Okay, so for the first exercise, if we want to actually view what's happening in that channel, we can use index.view, the same as what Evan showed before. We can save that very quickly, and we can just run the script again. Just take a wee second to run. I've called it the wrong thing. My apologies. We typo there. Index.channel, click view again, run. So you can see here quite often that when you do make a silly mistake like I did, it actually tells you where the mistake is, which is really nice. So you can see here at line 37, which is in the script here, it couldn't find index, but I've now corrected that to index_ch, and it says come back and run successfully. And here what we can see is it's just printed out the contents of that channel, which is this path to the work directory, which is here. So what Salmon has done is it's actually indexed that transcriptome file, and just to actually see what's happened in that file, you can look at the work directory. You can go into that specific work directory. So you can see here, again, with this hash, which is 15.5e, you can autocomplete that. You can see that there's a Salmon index, which is what it's created, as well as it's actually staged this transcriptome file. So what it's done, what Nextflow has done, is it's gone away and it said, I want this transcriptome file, it's brought it in and staged it in this work directory. So everything's localized in this one, localized so it can be accessed by this process. And it's executed this command and produced Salmon index. What we could also do is look at the tree of this. This is just the breakdown, and this is everything inside that folder, which has been created by Salmon. And as you can see here, this is actually just a symbolic link to the file, to the transcriptome file, which is sitting in the workspace over in here in the data folder, which is somewhere up the top, just up in here. Data, gggal, there it is in there. Okay, great. So we're just going to jump straight to script 3, try and keep things moving. Again, what we're going to do is just quickly run the script and see what happens, and then we're going to talk about what's probably happening behind the scenes. Just close these for clarity. So as you can see here, this is actually kind of a step back on that script that we've just created. And we'll come back to what we've achieved in script 2 already. But here, what I'm trying to introduce is this operator from file pairs. So we have these things called channel factories, which when you try and bring in this information, this data, these strings from into Nextflow, you can use these channel factories. Up until now, we've been using this channel off when we've needed to bring in a piece of data, but sometimes it's much more complicated than that. You might have combinations of file pairs, you might have different patterns of data that you're trying to bring in. So what we're doing here is we're bringing in from file pairs. And this is, I think it's probably one of the most useful channel factories, especially if you're dealing with sort of paired end Illumina data, for example. So what we can do is we are just going to read. We're actually going to look at the contents of that channel. So what you can see here is we've got this little bit of information at the front, which is gut. And then we have this paired piece of data, which are the two different transcriptome files for gut1 and gut2. So actually breaking this down, what's happened is that from file pairs has gone in and it's looked at this string, this read data, and it's said project directory data gggal gut 1 and 2. So that's just kind of acting like it can either be 1 or it can be 2 with the prefix of gut. And what it's done is pulled out that prefix value gut as a value and then given us the path to these two files. So this is a really nice way of doing it. And what we can actually do is add in some glob patterns to actually identify or include additional data in that folder. So what we can do, again, I'm just going to do this relative to the path, but you could sort of do the whole project dir thing, but I'm not going to do that just to make my type a little bit quicker. Data gggal. We're going to go for a glob pattern, so it's just going to include every possible combination at the start. .fq. Let's try that. Oh, it doesn't like that. Why doesn't it like that? Oh, it's probably because I've done this. Still got an error there. All right. Let's just change it up here for now then, just to keep things moving. Oh, we'll get rid of that. Nextflow run script 3. Cool. So what's happened here? Probably can't see now. Let's close that for a second. As again, we've got gut, liver, and lung. So these are the 3 different types of data we've actually got in this data repository here. So again, it's gone through. It's looked for that prefix, all that kind of common information at the start of these reads. So gut, liver, and lung. It's worked out that that is a value rather. We have these paths here, which is really, really nice. One thing we can do here as well, and this is, some people like it one way, some people like it another, but we can actually change this so that we don't have to sort of specify this using the equal sign. We can use something else called set. And what we can do is just channel. So again, this isn't this isn't for everyone. Some people like it. I think actually it should be curly brackets. But we can call this read pairs channel. So my apologies, we've kind of jumped a little bit here, but we can use this other operator called set, which is just going to define this way. And of course, like when we do add out the operators, kind of flatten and other things like that, you kind of just chain them in the middle. And this is probably how I do most of my coding, just because I find it a bit more intuitive that you kind of start at the top and work your way down so you can follow what's happening with the data. So again, here, we're just going to run this again. I've just saved this. We should get the same output. So that we're hitting set read pairs channel.
You've written Paris in the set.
Thanks, James. Read pairs. Yeah, there's a silly mistake of mine.
No, sorry, line 18 has got a new typo, but line 19 also has a typo. 19 is, and then line 18 should be AI flipped.
There we go. Read pairs, read pairs, read pairs. Thanks, James. There we go. Success. So yeah, obviously the debugging there, you can see on line 18 that I was making a mistake. James quickly picked that up for me, but I got all flustered. But here you can see channel from file pairs, and we've just used set. And again, we're just viewing that. But sometimes you don't want to sort of just proceed with your entire pipeline. If you're a little silly like me and made a mistake, you can add in kind of checks. And this is especially important when you are dealing with big data, when you're sending things up to the cloud and you don't want to just sort of, potentially spin things up and leave them running for a long time. So you can sort of add in these extra little bits to kind of check if your data exists and if it's there. So whenever we use an operator like this, there are quite often extra functions that we can use to check. So the Nextflow documentation is very, very good. As I said earlier, like there's all this information on channel factory, so there's a lot of different ways that you can bring in data, but sometimes you need to tune that to make sure that it's working properly and specify if it's a type, how deep you want to go when you're looking for a file, if you should follow links, what size you're expecting, if it's going to be flat or not. Here I'm just using check if exists. Which is when true, it throws an exception that the file path doesn't exist. So I'm just adding this into my operator from here, from this channel factory rather. Check if exists true, and we can just run that again. Cool, and that works. But for example, say we change this to something a little bit more complex. Let's call it leg data. Cool. So this is going to spit back this error message here saying that this doesn't exist. And this is because we've used this check exists equals true. If we didn't have that, it's still going to spit back an error, but I don't think it's going to be quite as elegant as that. It doesn't spit an error, it just runs. So this, because we weren't expecting, we weren't checking for the error, it didn't look for it, meaning that we didn't get that nice error message telling us what was wrong. And this is the check error. The check if exists is a really nice addition to add in, especially when you're bringing in data like this. So just because we are moving quite quickly, we do need to keep powering through this content. We're going to jump straight to script. Script 4, which again is just sitting down here. This is going to be much closer to what we've seen already in script 2, but we're going to be adding this quantification step. So again, we've got this quantification, which is another process. We've got the input. Here we have both the SAMP index as well as this tuple. So a tuple is just the kind of combination of this different pieces of data that's been stored together in the one sort of channel process. Here we have this value, which we have specified as sample ID, as well as the paths. So what you might remember from earlier is that we had these channels, or we created this channel as an output from the file pairs. So when we looked at that, it was the same as, I guess we can just quickly jump back to script 3. We'll just change this back to gut. So we see this here, that is this gut, and then these 2 file paths. So with the gut, this is the value, and these are the 2 paths that we're expecting. And then we're seeing this here, it's this tuple. So this becomes like, in this example, gut. And here we're storing the 2 different file paths as reads. For the output, we're just going to specify sample ID. And this is an example where we're using dynamic naming to actually name the output from this process. So here we're actually going to use the sample ID, which we've used as an input, to name the output, which is really nice. And this is a really good way, especially when you have lots of samples, you can kind of carry this information around as values. You can even map this and use kind of different things from potentially a set of metadata to name this data and include information about it as you sort of carry it through this workflow. Down here for the script, this isn't anything special, but again, we're using salmon. We're going to use the quant. We've got the threads here. So this is similar to what we've done up here with the tasks.cpus. We've kind of got this lib type, the salmon index, which is specified as the path. So this is the output from the index process. So here we've specified as salmon index. We could rename this. This doesn't have to be anything in particular. We're just going to keep it the same now, but we could just quickly rename it to something like that, and that would still run. It's really just you're giving it this name as an input, and you carry that through into the script when you're actually running it. Here we're using reads 0 and 1. So again, up here is we've got these paths. We've just indexed them as 0 and 1 because we've got the 2 as a part of the file paths in this as this input. And here again, we've got like this specified value as the sample ID. So what we will do is we're just going to quickly run this again and see what we get as the output. Oh, 34, that's going to fail. Cool. So here we've just kept it to the one sample, this singular gut sample that is specified up here. And as you can see, it's kind of just taken the one sample, it's taken index, and then it's just as indexed the transcriptome file, and then it's quantified it using this quantification process. We're actually going to make this a little bit more complicated, a little bit cooler, by adding in some extra data, and we can also add some other things called tags, and we can set a publish directory, which is also very, very useful when you're sort of dealing with lots of data all at once, outside of a simple example like this. So what we're going to do is go reads. We're going to go data, gggal. Here we're going to have lots of different options because we've got all of these different files in this folder. We're going to just add a glob pattern at the start to include all of those. We're going to go for the paired data .fq. Don't need that one there. So here we're just actually going to address all of this data, and we're going to use the resume function, which we'll talk about a little bit afterwards as well. So again, we're going to go through the same process, Nextflow run, script 4 in this example. We've changed the read, so this is going to override what we've actually specified up here in the main workflow script. We're going to use resume just because it's going to add a cool functionality that we'll be able to demonstrate as well. Cool. So this has all happened quite quickly, but what we've actually happened here is we've got this cache, this word cached at the end of this line. So what that means is that we've actually pulled this again from the cache. So Nextflow knows that you've already run this, so it doesn't need to run it again because this hash is the same. You haven't changed anything about that process, and it's used as cache data What we can't see, I'm just going to move this work directory and run it again, is that quantification also used the cached information for just that first sample, which in this case would have been gut, and then it's repeated again twice for the other two samples. So I've just removed the work directory, so now we've removed that cache, and we'll run it again. The resume function won't work, but it doesn't actually hurt having it there. It's not going to spit an error or anything like that. It's quite a cool name, Gigantic Crick. Cool, so here it's a little bit slower, and as you can see, these numbers, there's a number here, and I'll talk about that in just a second, but we can see 3 of 3, meaning that it's run it 3 times. So once for each different set of data, being the lung, what type of data it is, the lung, the liver, and the gut. So this is nice. Here it's just given us a number telling us which set of data is run through, but we can also use these things called directives, which I mentioned earlier, to kind of tag this information and actually give us something a little bit more informative when we're looking at it. So tags are a really nice way of sort of just, like I said, labeling that data. I think in the example here, we use a different tag. So this is one of the exercises, so you're welcome to follow along and do this one as well. So we can just call it salmon on, and then we can just call it sample ID. So this is one of the cool things about Nextflow as well, is that even though we've kind of specified sample ID beneath this in the process, Nextflow still knows that it can use this in the directive, which here is tag. As another example, you can also sort of change the number of CPUs, which is nice. Nice autocomplete there to show us what's going on. If you're using Gitpod, I think there is actually a reasonable amount of resources here. But we can specify here, for example, CPUs 2. But up here, for example, we can add a completely different directive, which we could say 4. So again, let's quickly save that and run it again, and we'll see if we can see any differences when we run this. Cool. So it'll happen quite quickly, so I'm just going to clear this and show it again. Resume. So if you watch quickly, so it's the first process, nice and quick, and then 1, 2, 3. You can see here that we've actually tagged this with salmon on lung, which is what we've actually specified up here. You probably don't need to specify on salmon. You could just have a sample ID. You could make it more descriptive. Today, I am processing this. And again, you can just run it again. It'll be nice and quickly run. And what we'll see, today I'm processing lung. So again, let's just process that really quickly, but it looks really nice. The other exercise we have for this module on the training material, or for this process with script 4, is actually adding in something called a publish directory. And this is a really nice way of kind of organizing your data, especially if you have multiple steps and quite big files, and you want to say, I want to keep this, I don't want to keep this, I want to store this here, I want to make this a symlink, I want to copy this. There's lots of really cool ways that you can sort of organize your data. So what I'm going to do is just try and bring this up quickly and just share it with you. So again, this is one of the directives, and there are a lot of different directives here, and we don't have time to talk about all of them today. We'll talk about some of them again tomorrow. But when you sort of use this publish directory, you can add it in at the top, and you can specify exactly where you want that data to end up, and also where you want to store it. So today, as part of the exercise, and just to keep things moving, I'll give you sort of 30 seconds just to try this. Again, this is a part of the training material. I think it's in section 3.4 if you get stuck. So it's about 30 seconds to try and add in the published directory yourself, and then we'll quickly go through the answer. Sorry, just unmute. So what can happen here is, again, just add another directives, and you can just sort of keep piling these directives in depending on what you're trying to do. Here we're using the published directory, which is the name of the directive. Excuse me. Here we're specifying the params.outdir, and this is the same as what we've specified up here, but we don't actually need to do that. You could call it something completely different. You could call it results2, just anything you want really, or even something probably more descriptive, like you know, you just call it quant or something like that. Probably put them in brackets, but today we're just going to call it the params.outdoor, and we're going to copy it in this case. So depending on the data type, the size of the file, you might sort of say, I do want to keep this, I don't want to keep this, I want to copy it, I want to symlink. Again, lots of options. So just to sort of show my directory at the moment, we don't actually have a results folder. But what we can do, I'm just going to clear that, is run this again. Again, this is just sort of the basic Nextflows. Run Nextflow. Here's this log information we specified right at the start. Index, quantification, today I'm processing gut. And now when we look at it, we can actually see this results folder. And when we look inside that results folder, we can see all this information. That is all the quantification information. Probably not a particularly good example there, but a little bit easy to see. And we can sort of dig down into this and see all the information there as well. So that is really an example of, it's really a taster of what you can achieve with Nextflow in terms of, first of all, sort of really tuning each process to potentially like allocate different number of CPUs, adding some nice tags so you can see what's going on, as well as storing that data afterwards. As I showed, there are like a lot of different directives that you can use, and don't be afraid to sort of have a play around with those in your own time. So script 6 is again a little bit, I guess we'll go to script 5 first, my apologies. Okay, so this is just kind of jumping the gun a wee bit there, sort of just adding all of this on to script 4. But again, this is just the information that we've done. Here we've just added in this extra step here for fast QC. Fast QC, I guess this part of the training, script 5 in particular, this is more relevant when we're using Dsl1, where you actually had to kind of split a channel so that you could use it twice. With Dsl2, it does this automatically, so you don't really need to worry about this anymore. But just because it's included, we'll just talk about it very briefly. Again, we've got like a tag, which is fast QC on sample ID. Again, we've used a sample ID from the input, which is that value that we derive from using from file pairs. We've still got the read sitting there. We've got this output, which in this case is fast QC underscore sample ID. Again, we've used that sample ID from the value from the input underscore logs. So this is kind of like standardized, sort of putting together some string values with variables in a script or as an input. And then we're sort of running a basic fast QC execution, which some of you are probably familiar with. But we're just creating this directory, which is this log, which is this folder here, and then we're using fastqc, which is taking in the reads and the sample ID and executing just the fastqc analysis on that. In this workflow channel, things again are pretty much the same. Like I said earlier, we've got this from file pairs, which we're taking in these param reads, which are from right from the top. We're checking if it's true, and we're setting that as the read pairs. And we've already talked about how we could have done something like read underscore pairs. No spelling mistakes this time. So you could have just done something like this and then completely removed this bit here. But it's just fine doing it this way as well. This is how I like to do it personally. So again, here, for example, you could do something like set index dot. So we could go through and change all of these if we wanted to. It doesn't really matter too much for these purposes, but it's just to kind of demonstrate that you can kind of like, there are different ways to do the same thing. So Nextflow run script 5. Again, let's take a wee second to run. So again here at the top of the script, we've just got gut. In the past, we have overwritten this in the command using the reads. Just for ease, we're just going to use the glob there. And we're just going to run it again, just again to demonstrate that even with extra data, more files in this sort of input parameter, this is going to split those off and run them in parallel, which is a really, really nice way of doing it. fastqc is just going to take a little bit longer. Okay. So I don't want to dwell on script 5 too much. We're just going to jump straight to script 6, especially because we still have a lot to get through. We're talking about the containers in Docker. So we're just going to go straight to script 6 here. Again, not a lot has changed, but I'm just going to keep adding on another process. So everything up until here, fastqc is the same, but now we're also going to be using multi-QC. And this is another really fantastic feature of Nextflow, that we can use operators to really split channels apart and sort of bring them back together when we need to, because sometimes you don't want to run one process on sort of one set of data. You might want to run it on the data collectively. And that's the same for multi-QC, where we don't really want to run multi-QC and produce a different report for every different sort of file combination or every sample, but you kind of want to produce that report for everything together. So we're just going to play around with this workflow a little bit and talk about mix and collect, just to kind of show you sort of how these things work and how, really demonstrate how this might benefit your own coding or your own pipelines in the future as well. So again, Nextflow run script 6. We still have just gut up here, so it's only going to be for one sample. And what we can see is that we're going to sort of use this index quantification, 7 on gut, fastqc on gut. This is going to take a wee second. And once all of these processes are finished, Nextflow knows that all of this is now available, and it can actually start pumping it through into the multi-QC. So this is something we haven't really talked about, but when the way Nextflow works is that when these channels are full, it'll drive the process forward. Nextflow can't start multi-QC because the outputs of fastqc channel, this hasn't been created yet. So until it's used the read pairs from here, which you don't really get until you've done you've created them here, you can't start fastqc. It's also needing the quant channel, and that hasn't been produced yet because you need these other files first. So when all the criteria for that, all the needs of that channel have been met, then it will drive that process forward. So here, multi-QC quant channel.mix, we've got it for one sample because it's only got the one sample available. But when we potentially change this back to the glob, and we can see we have the multiple samples included. I'm just going to add resume here to keep things nice and quick. So again, it's only done it. It can only do these processes as parallelize them, but this multi-QC process has to wait until everything has been created. So just to kind of break this down, what we will do is just have a look at some of these channels. Quant.channel.view. Okay, so here what we can see is that there's a different channel for each of the different tissue types, and this is purely just the folder, the path to the folder. We can do the same for the FastQC channel. Again, we're just going to quickly look to see what it produces, so we have an idea of what we're working with. I've left off a bit there, that's my mistake. Cool, so you can see here, this is actually the output of FastQC, in which we can check the output, so actually what's in there. It allows you to paste, yes. So as you can see here, we've actually got these FastQC files, which are the HTMLs, as well as the zip files there. So this is just the output of FastQC in this work directory. We haven't stored that anywhere else at the moment. So, sorry, excuse me. So when we want to combine these channels, we can use operators. And operators is something I've sort of mentioned a couple of times, so it probably doesn't make a lot of sense. Again, there's really, really good documentation on different operators and how they work. That's all on the Nextflow website. I'll just bring that up quickly, just so you can have a quick look at it. Operators, nice big section here. There's different ways to filter, transform, splitting, combining, forking, different maths operators, as well as all these other operators here. There are probably like maybe a handful that you use quite frequently, and some of these others are probably more of like edge cases where you're trying to do something a little bit cooler, a little bit outside of the norm. But the documentation is really good, so don't fret about and not knowing these. Some of them are quite similar to what you'd expect from Groovy, but it's not a big deal to kind of sort of become aware of what these do. So jumping back to this, if we just were to look at we're going to remove the multi-QC process for now, and we're going to look at this as an output. So here, what's happening is we're taking this quant channel, we are mixing it with the FastQC channel, and then we're not going to collect actually. Let's move that off for now. So we're just going to see what happens when you mix the quant channel with the FastQC channel. What does that output look like? So let's move it up, make it a bit more visible for everyone. Cool. So here what's happened is it's just mixed these two channels. So up above, when we just looked at these in isolation, so when we looked at the quant channel, we viewed that, and the FastQC channel, when we viewed that separately, we could sort of see each of these as separate channels, and we know this because they're printed out as separate lines like this. Up there's the rest of them. Here, by mixing them, we've just added those together. So now all of this is mixed, but they're still separate channels. What we want to do is kind of collect all of these into one single channel. And that is what we're going to do just here. Dot view. I think that should be okay. So what you can see I've done here as well is we'll kind of just chain these on top of each other. And you can kind of mix up this a little bit as well. You might sort of say, I want to do it like this because I find that easier to look at. So again, it's just mix that we're going to collect and then we're going to view it. View kind of being that bread and butter way just to print this stuff out to the terminal so we can see it nice and easily. Just taking a wee second. Cool. So what you can see here now is that we've actually got all of this included as one channel. And we notice because it's got these square brackets around it. So you can kind of see this first one here, comma, second, comma, third, comma, blah, 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 all the way down. So instead of having these as separate channels, they are now all included in one. We can sort of double down and make this, call this a set, and we could call this anything we want. You could call it single channel, and we're just going to set that as a name. Then hypothetically, we could do your multi-QC on this single channel. This is a little bit different to what you'll see in the training material, but it's just kind of illustrating that you can do this stuff like lots of different ways. Got the resume there. Again, it's just going to go back and it's going to say a lot of this stuff is cached, so we don't need to run it again. All those hashes haven't changed. And we've run multi-QC. What I might do is just quickly clear the work directory, so you see this all the way through. And we haven't actually set this as anything, so we could sort of set this as another channel as we want. It doesn't really matter because we're not going to be doing anything else with it after this. We'll just run that again. These steps can take a wee second. Still got this view in here, so we're getting that print out to the terminal. And we've got this multi-QC, which has run. We haven't stored the outputs anyway. I don't think we do have it. So we can actually check that in the results. We've got that nice multi-QC report in there that we could open up and view if we wanted to, but we probably don't need to right now. Okay, so jumping on to script 7. We'll just see if there's any what my notes are for this, just to make sure I know what to talk about. Okay, cool. So up until this point, we've really just sort of strapped these 4 different processes together: the index, quantification, the fast QC, and the multi-QC. We've talked about how we can sort of control and fine-tune these channels with different sort of directives. From here, things can get a little bit more complicated, and we're just going to quickly demonstrate some of the more sort of dynamic things you can do with Nextflow. I'm going to have to move through some of this quite quickly, just so that we keep to time. So the first thing I want to talk about very quickly is everything else we've talked about so far is kind of very like channel specific, and everything's kind of isolated into those processes. But you might want to execute something, at the start or at the end of your workflow, and you can definitely do this in Nextflow. So here, for example, you can do this like workflow.onComplete. Here we basically have like an if-else statement. This is a little bit more groovy. Don't worry about it too much if you're not familiar with groovy. But you can just use this log info again, the same thing that we use right at the top of the script. Just to print out if this is completed successfully, do this. If it hasn't, do that. So here we're just saying open the following report in your browser, which is the params.outdir, the results folder that we specified at the top, the multi-QC report. If something fails and it hasn't completed successfully, oops, something went wrong, which is quite a nice way of finishing off the script. Cool, done. Open the following report in your browser. And we could definitely do that if we had more time. What I also want to talk about here is that you can also do these other kind of like, I'm not sure quite what to call it. This section is called quality control. But I haven't got this set up on this computer, but if you have your own sort of SMTP sort of setup with emails. You can say send me an email once this workflow is finished, and that's quite a nice way of doing it if you are doing a lot of sort of sequencing off a core facility type platform. There's lots of documentation on this. I'm just going to copy and paste this very quickly as an example, but so sometimes we have these processes which are defined or using other tools, but say you might have your own script. For what we're doing here, it obviously isn't as important, but you know, say you had like a big long Python script or an R script or something like that, something else like that you wanted to use in your workflow. You can actually just include these as a part of your workflow process. So Nextflow knows to look for a bin process. So in here we don't actually have it set up, but we can just quickly do macdir bin cd bin. It's nice and empty. I'm just going to quickly use nano. So what I'm putting in here is just like a shell script, as you might expect. This is everything that's in that FastQC process. Today, I'm just going to replace that FastQC tool, this script, just to kind of demonstrate how this can be done. Control X. Yes, I want to save that, and I'm going to call it fastqc.sh. Now we have the FastQC sh in there. What we do need to do is just make sure that this is executable. So we're just going to do that. I've already put a bin inside a bin. Oops, daisy. We're just going to go back and do this again, just because it's going to be a little bit quicker. Me trying to type all that out and check that it's working. X, yes. Fast qc.sh. I got a little bit excited there and used I just copied some of the code from the tutorial rather than typing it out myself. So now we have this bin, which is going to have we're going to have this script in here as well as this other bin. I'm just going to remove that in case there's going to be any weird conflicts. So what Nextflow knows to do is that instead of looking for this, Nextflow knows to look for the bin directory within this sort of working project directory. So we can just specify fastqc.sh, and we know that in that script that we just created, I actually set the two arguments, which I can show very quickly. At bin fastqc.sh, it's asking for the sample ID and the reads two arguments. So what we can do is replace it in here as a script. We've got script 7 there. So we've edited it. Let's type this out. Here we go. And it's just going to execute this like any other script. So this is a really good way, like for example, like I said, an R script or a Python script or something like that. You can kind of install it and have it as a part of your pipeline without having to sort of go away and pull it in from elsewhere. Again, this is running really nicely. One thing I haven't talked about, I don't think we're going to have time today, I'm sorry, but like if you jump into the work folder, C2, 48, you can see there's a bit of stuff there, but there's actually these hidden folders here, and you can go in here and actually check out what was explicitly run. So this is actually like the whole script and what Nextflow has done, but probably what's more interesting is this command.sh. We can actually see what FastQC is taken in and how it's actually run this script. And you can do this for any of the work directories or any of the processes to run. You can go in and actually look at exactly what's happening in the hood as part of Nextflow. One last thing, and I'm apologize, I can't dwell on this for too long. But when you, it's a bad example now. So one thing is that you can actually run Nextflow not just from local scripts, but you can run it from like an online. You can run it straight from Git, I guess is what I'm trying to say. And I think this will come up again a little bit later. So I don't think we will stall too long on it now. Yeah, we'll skip this for now. But basically what you can do, script 7.nf, and I've typed 8. You can get all of these really nice like reports and traces and timelines and DAGs and PNGs and stuff like that. So this is just like a nice way of reporting. Some of this has kind of been superseded by stuff like Tower. And you can probably like mine a lot of this stuff from a fast QC and multi QC report anyway. But it does produce these really nice reports. And we're going to get a lot of these turn up in our folder here. Like for example, trace. Where is that? Trace.txt. So you can kind of see like all this information about where it was run, where it was run, how it was run, and how much resources it took. Get this DAG PNG, which is this kind of like this nice representation, lines being channels, circles being processes, these dots kind of being the operators, a really nice way of visualizing what you're doing. So we're going to jump to something else now, which is kind of an aside. We could talk about Nextflow a lot more, but we will talk about kind of like some of these like these ideas, these concepts a little bit more tomorrow. But we've got when we talk about channels and operators and processes a bit more in detail there. But today I want to talk about Docker very quickly. Docker can be quite scary when you first start with it, but it's really worthwhile once you understand it a little bit more. So what we're going to do is just clear that, basically to start kind of like this new idea, this fresh idea. Docker's a little bit similar to Nextflow. Sorry, excuse me. In that you have this Docker run, much similar to Nextflow run, with a container name. So Docker's kind of like a container management software. I really encourage you to go away and check out Docker, some information on it if you haven't really heard about it or used it already. But the main idea is that it's kind of as a container platform that is building these tools, or is storing these tools with all the kind of like underlying dependencies and everything else in a really contained and organized way. And it just basically enables you to either use your local version or a version on Docker Hub, which is like a repository. You can pull those into your pipeline and run them 100% reproducibly, which is really fantastic, especially to make everything really portable, but also really reproducible. So just for the example today, we're going to use this example of Hello World. And what's happening here is Docker is effectively printing out what's going on. So just sort of working this very quickly, it couldn't find Hello World locally in my local sort of Docker repository here. So it's pulling it in from Docker Hub. It's pulled it in. It's telling you what's going on. And it's got this daemon working in the background. Basically, it's kind of like monitoring what's going on. And it sort of says, don't have it locally, go to the hub, cool, in the hub, pull it in, stream it out here. So it's kind of getting escalated and then coming back down to actually just print what's happening here, which is really, really nice. But this is really just an example to show you that sort of like this idea that's going up and down. We can also use a thing called Docker pull, which is actually going to pull in a Docker image from, in this case, Docker Hub. So what we've done here is I've just pulled in Docker Debian, which is stretch slim, basically the version number. It's a very, very light container. And here I've just quickly typed in Docker images, which is just a way of saying what images have I got. What's happened here is we can see that this image has been technically brought in and has been stored locally for me now. So what you can also see here is this Debian, which is a really sort of relatively small. Hello World, which I've just run. Again, I didn't have that locally. It's gone up to Docker Hub and pulled that in, and I have it sitting there locally now, as well as this Nextflow, excuse me, RNA-Seq NF, which is substantially bigger because we've much more in there, 7 and other things, for example. So this is all fine. This is kind of like gone up and then come back down and says, let's run this. It spins up, says, cool, here it is, spins back down. I don't actually have that running anymore, but you can run it in an interactive way, which is what I've done here by just typing docker run, basically interactive, this image in bash. And what you can see here is actually this is a completely different file structure to what we're expecting. So again, you can exit out and just show that I'm sort of sitting here with all of my nice local NF core files. But when you sort of run this again, it's different. You can also look at who am I, and you'll see here that you have root, meaning you have sort of root privileges and your user ID is root. But again, when you exit out, you can go who am I, you see with Git pod. So we've got a little different profile is effectively what's going on. So what I'm just going to demonstrate very quickly, just because we are very quickly running out of time, is basically how you can build a Docker file. I'm just quickly making a Docker file or a Docker folder, then moving into it. Because if you execute this in a folder with other stuff in it, it'll bring it into the image, which you don't really need. It's just going to create it a lot bigger and heavier than you potentially want it to. So here I've just used Nano again very quickly. And I've just copied this from the training material. I'll be able to go back and have a look at this in more detail. But yes, you can see I've got this Docker file. So basically what's in that Docker file is it's kind of just instructions for building this image, this Docker. So saying go back, use this Debian stretch slim. Here I could put in my name if I wanted to. Here I'm just saying at Git, which is where I'm pulling stuff from the web. And I'm basically bringing in this thing called cowsay, which is just a cow which can talk through your command line. And yeah, so that's basically what's happening there. And then what I'm going to do is quickly build this image. So again, this is just working through what's happening, or it's working through those instructions I had in that Docker file. And it's just saying, go away, bring this in, bring this in, bring this in. And it's going to build it and call it by image. And as you can see here, you can call it different tags and things, but we won't go into that right now. If we go back and look at Docker images, you now see that we've built this image, which is my image. And then we can kind of run Docker. Okay, so I've copied it in, so I'll show it again. Docker run my image, which is just this image that we've created just up here. We can use cowsay, hello Docker, and we run that and we get that. Get out a nice cowsay-ness. You could, hello APAC. That'll run nicely. The thing here is that we can show that cowsay wasn't found locally, but only when we run this as a Docker image. So what we can do here as well, we could just quickly show that my image. So we can go in there and do cowsay. Hello, there we are. So again, this is happening in the Docker. It's not happening on. It's a different environment to what's happening locally for you in the terminal. We are probably going to run out of time to do this in great detail, but we'll start anyway. So again, all I've got in here is my Docker file, nano Docker file. So here we can add in basically information to bring in anything we want. And this will just like iteratively work through to sort of build this Docker image, or this Docker file rather. So here we're just adding in salmon just to actually demonstrate that you can use this with real world examples, not just these sort of artificial kind of like toy examples. You can see here this burst happened really, really quickly because we've already done that. We're just kind of building on top of that image already. Here I'm just adding in salmon. I'm just curling it from GitHub, and then just kind of installing it using just some sort of basic bash commands. So just as proof of concept, Docker run my image salmon. So this is just again, we've got this my image. It's a little bit bigger now, and we've got salmon inside of it. So Docker is wonderful, but it's also a little bit more complicated in that it's not always as easy to run some of these potentially scripts. I might just clear all that. So again, we're just going to run Docker with my image, but sorry, excuse me, talking a bit quickly. While we can run this in a container and it's going to work, it's not actually mounted on your system. So there is going to be some disconnect between the files you can see, what's happening in Docker and what's happening locally. Purely for time's sake, I do encourage you to go back and actually look at some of this material here. So we sort of get up to here, we've just added this into our Docker file, we've just built it again. You can see that salmon is running. But we're going to hit errors because basically what's happening in Docker isn't necessarily happening on your system, and you need to mount to make sure that everything is connected. So here, this is probably the example we want to get to. This may or may not work because we've jumped a couple of steps. Okay, so it's going to be an error because this is, we pulled in an older version of salmon. But this, I know why that's not working. I'm in the wrong folder. Yeah, there we go. Basically what's happened here, I was in the wrong folder, which didn't help. But we need to mount the Docker volume onto the local volume, and that's what's happening here. We're also specifying that this is your work directory, which is a local directory, basically where this command is being run. Use this image as well as the actual command. You can also do cool things where you can actually push this just straight up to the cloud, and also onto your own Docker Hub. Again, this is shown in the training material. Here, so we could use like Docker login. We won't have time to show this today, but you can log in. You could retag this image because what we've done is just kind of called it latest, which isn't always the best idea. You can push your image up. Again, you could use your username plus my image, and then it'll be stored basically externally on Docker Hub. And then you or anyone else can pull this straight from Docker Hub to use. Probably the main thing I want to finish on here is that this is just using the Nextflow RNA-Seq example, like actually pulling it from Docker using for this Docker Nextflow image. But the cool thing here is that you could, I don't think this is going to work, or it might work. So I'll sort of crash that, clear. So here we're just going to run Nextflow with Docker. This is already going to have the Docker, everything set up from our config earlier, but I'm going to use my image, which we've just installed salmon on, and it'll work. So it's pulled in basically this Docker image, the one that we've just created, and it works really nicely. Just because we've kind of hit time, we'll touch on this a little bit tomorrow, but just very quickly, singularity works much the same. It's probably better for like local HPC environments where you don't need to kind of have this daemon working in the background, but Docker has its benefits for cloud computing. Again, like you can basically just use singularity to pull the Docker image, or pull a Docker image, and then it'll create the singularity image, which needs to be stored locally on that HPC system, which is really nice. I'd encourage you to go away and have a quick look at this material as well, where you can actually use Conda to create an environment, which you would have able to use, like, which you kind of basically install all the dependencies, basically using a standard Conda environment, sort of create. And then you can use Docker, or Micro Mumba, I think it's called. Yes, Micro Mumba, just about got that wrong, to take this environment, YAML, and turn it into a Docker image for you. And that's basically what's happening here. So you kind of get the best of using Conda, which is really good, but isn't always as reproducible. You can basically use it to create this environment, push it up to Docker Hub, other people can use it. It's got your dependencies nicely sort of interwoven. Excuse me, but it's a really nice way of doing it. And there's a lot of benefits to this as well. Especially with biocontainers as well, which is kind of a place you can store this. So that's probably where we're going to end it today. I'll try and pick up on this a little bit tomorrow, sort of just refresh some of the stuff that I've skimmed over here. But apart from that, thank you for attending. If you have any questions, please keep putting them into the APAC channel. James and I will sort of continue to monitor that for the rest of the day and tomorrow. And yeah, we will pick up again tomorrow. Thanks so much, and we'll see you then.
Good. If